Okay. All right. So I came here tonight to talk about. Am I in my way with the slides? Okay. All right. I'm just asking. To talk about computer vision with Python and OpenCV. So when I was making the slides for this presentation, I wasn't totally sure if I should give a big, huge, broad overview of computer vision, or if I should just focus on the what I'd use for my project. And kind of a common theme with computer vision is that you'll be taking an input and then doing analysis and then extracting a result from that analysis. That's a pretty common pattern. So I just decided to sort of laser focus on this one thing that I worked on in hopes that you can use the information to work on or explore any part of computer vision that you'd like. So that's that slide. I'm going to read off this slide because I can't remember all of this, but this is from Wikipedia. Computer vision is a field that includes methods for acquiring, processing, analyzing, understanding images, and in general high-dimensional data from the real world in order to produce numerical or symbolic information in the forms of decisions. And that is what OpenCV does. So it's a collection. OpenCV is basically this open source library that was developed by volunteers, and I think there's a company now that sort of is at the helm of maintaining it. Basically, it's this collection of algorithms for working with computer vision, and it's written in C++, but there's bindings for Python and Java and several different languages. But the focus that we are going to be I'm going to be talking about tonight is the specific bindings for Python. And another fun fact, OpenCV was actually used on an autonomous car. So a self-driving car that won the DARPA challenge back in 2005. So sort of shows you the credibility of the code behind the project. So what exactly is Python OpenCV? Basically, it's a wrapper, from earlier, it's a wrapper for OpenCV. And the cool thing about it is under the hood, it uses NumPy, which is a very, very, very fast library for doing computation. And it has its own implementation for arrays that are much faster to work with than the standard native arrays. And as luck would have it, all of the arrays, I can't remember if I said this or not, but all the arrays in OpenCV are NumPy arrays. So you get the benefit of working at a lower level with a higher level language, which is really nice because that means stuff is easy. So why OpenCV Python? So when I first worked on this project, so kind of back up a little bit. So the sound synthesis software I have on my computer is written with Overtone, which is a Clojure project. So I got the bright idea to also do my project I'm working on also in Clojure. But so just to show you the board that it's running on, it's this little Banana Pi. I actually I don't know if I'm okay. So it's sort of like an enhanced Raspberry Pi, but still you're kind of limited in computational power. And Clojure runs on top of the JVM or Java, and it wasn't as fast as I wanted it. So I redid my prototype in Python, and it runs really well. Super happy with it. So it's it's great, and it's really easy to write in or to use, and it's fast enough to be more than a prototype. And it runs anywhere where Python does and OpenCV does, which is pretty much everywhere. And this is it's running an ARM chip, by the way, if you're curious. Okay. So, all right. So what the heck can you do with computer vision anyway? Lots of different things. pretty popular subfields of computer vision include OCR, to recognize and extract text. And I think somebody at the last meetup asked me to do a demo of this, and there's actually exists very good demos for showing how this works. Object recognition, so let's say you're holding a ball. Maybe you want the camera to detect that there's a ball in your hand, or maybe you want the camera to detect like where your eyes are, so things like that. And also motion detection. This is what my project is built on. So I'm gonna, like I said earlier, I'm gonna only cover motion detection, but I hope to do it in detail enough that you can extrapolate and use, get a better foothold of the OpenCV Python library. So I've been talking about my demo a lot and not explaining it, so this is what this slide is about, and hopefully I explain it without having to stare at a slide. But so what my project is, it's a camera, and it's hooked up to this this little mini computer, and what it does, it takes in it takes in images through the camera and uses computer vision to detect if motion has occurred. So maybe I could give a quick. And I have it mapped to an 8x8 grid, and each cell in the grid represents a node. And the image processing software on this computer is sending a packet over to that computer with the grid that was activated. And when that computer receives that packet and parses it and whatnot, it plays a note, and it's pretty quick. It's not that bad. And so I have it mapped to a specific pattern musical notes, and if you're curious, this is a D minor 7 chord. Yeah. So now, if I have this running while I'm doing the presentation, it's gonna be really annoying. So I'm gonna put the bag back on. Okay. All right. You may not be able to read this. I'm gonna try to do my best to make this bigger. And that is totally not working. Let me see if I get a full screen. It is? All right. If you might can't read this, just yell at me and I'll do a better job. Okay, so as I step over my equipment yet again, so I wanted to give you how I built up my project in a series of examples that builds up over my slides. And the first thing that, if you're reading it from a camera, you need you use OpenCV to do that. It's pretty easy. So you import the OpenCV library, and then you make this call, video capture, and it takes in an integer, and basically this represents the camera that's connected to your machine. You may have multiple cameras, like you may have 2 or 3. So in that case, you would use like if you needed to grab the first camera, you would use 1 or 0 index. You would use 0. If you need to grab the third camera, you would put it in 2. And basically, this is just a reference to the specific camera you want. And then I want to show it in a window. So I'm going to create a window here. It takes in the string, and it's a name window. It's kind of weird because you have to, like when you call the window, it references that string specifically. And if you don't reference that string, it won't pull up the window. It's kind of odd. And then we have our loop that will continuously read from the camera and display whatever's in front of it. So you have this image show, and we'll talk about that in a second. But the important part is this cam.read. So all that does is grabs the frame from the camera, and then you pass that into the window, and then your string for the name of the window. And something weird enough about PyOpenCV is that in order to open the window, you have to have this. I'm not really sure why. I can show you an example of that real quick. a second. If for some reason this doesn't work out, all my examples are in my GitHub repo. All right, cool. So that is me in my fuzzy hair, and it's reading the camera. And that example code does exactly that. And then, okay, let's go to the next slide. So an important part with working with images in general with OpenCV is that each image is represented as a NumPy array of arrays. And each subarray is basically an RGB value, or if you're grayscale, it's a value from 0 to 255. And what we'll be doing here, we won't be using RGB, we'll be using grayscale, because we don't really, we don't need that. We just need black and white to be able to detect that motion. And just to repeat, NumPy arrays are super fast, and that's awesome. Let's go to the next one. So with the easiest way to do motion detection with a camera is basically to calculate the difference between two images. So the idea is you have two images. If something changed, then the difference, say you have two black and white images, the difference between those will be you'll see some white. And I guess the best way to explain that is to actually show the example and show you the code. So here's my second example. So with OpenCV, you have this function method that allows you to subtract two arrays from each other, and this is what we're doing here. So we're actually storing these frames. We're keeping track of the current frame and the previous frame, and we're subtracting that together, and we're turning that result here. And it's basically the same code, except we're remembering the images, the previous and the current, and then displaying the diff image output. And I will run that example.
How many frames per second?
That's a very good question. Maybe, I don't know, but it's pretty quick. No, accidentally took a screenshot. All right. Actually, you can see, yeah. Oh, it's this camera. I forget, I have multiple cameras everywhere. All right, and then, so this is what I'm talking about. So if I stand still, there's nothing, when you subtract two images, there's gonna be nothing. There's no, it'll be zero. The difference will be zero. So if I move, you see this white. And actually it's gray, but regardless. So this is probably the most basic detector, but you'll see that there's kind of some artifacts here, and we can actually do some more image processing to refine. I have no idea what this looks like in the real camera, but I'm sure it's insane. You can clean up the motion detection a little bit by doing some extra processing.
So the faster you move, the brighter that image is going to be, right?
Yeah. And actually, if you see, I'm waving my hands really fast, you can sort of see the ductwork, and we want to get rid of that. You might see that at all. I can't because I'm really close. There's like some ductwork that I can see in the, yeah. So we can actually get rid of that with some image processing. Yeah. So there's a technique that you can use that I learned about and I was not aware of before doing this, where you keep you keep track of 3 states. So the previous, the current, and then like a state ahead. So you basically subtract well, it's right there. The current, or subtract the previous from the current, and then the next state from the current, or from, I'm getting this backwards. Probably better to read it. So I'll show you the code and it'll make more sense. But after you take these 2 differences, you perform a bitwise AND on the 2 differences. So what that does, you might have heard of image masking, where you take, you use bitwise operations to perform operations on images. I can show you all an example real quick, if that would help. Maybe. Let's see. I can't click anymore. Oh, it's because I'm clicking the, okay. Bitwise. It's a bit mask. Wikipedia, because there's actually, they have a really good example with Pac-Man. Yeah. It's here somewhere. Yeah, there we go. Right there. So basically, it's a pretty good visualization of like what happens when you perform these bitwise operations on the 2 images. So you have this one image and a second image, and you bitwise AND them together, and you add them together. In the OR, you take the here they take the result of the first one, and they OR the other one onto the result there. I hope that was a decent explanation. Okay. Okay, here's the third example. So the only thing that really changed was the diff image and then storing the third state. So here we are subtracting the previous from the current and storing that, and the current from the next. So we have these 2 states, and then we perform the bitwise AND on those 2 states, basically to remove the background. I'm going to show you what that looks like. Okay. So oh, I forgot to move it over. I'm dancing in front of the camera for no reason, apparently. Yeah, people are entertained at least. Okay. So I think, yeah, there we go. So you still see the motion that I'm doing, but you don't get all those artifacts from the ductwork, which is what we want. We want to remove as much of that as possible. But I'm still kind of not satisfied with it. It's too detailed for me. So we can still do some more image processing to get where we want. And let me get rid of all that. Yeah, so like I said, there's also some artifacts too that it's kind of, you have to take it into account the room too. There may be some differences in the lighting that can cause different artifacts. And when I did this in my apartment, I was getting these weird, like, light artifacts that were giving false positives. Like, it looked like a little dot. So we want to get rid of those, make sure that those don't happen. And so one thing we can do is actually erode the image. And what I mean by that, so you intelligently remove pixels away so that it doesn't, it distorts a little bit, but you don't change the overall shape of the feature. And this is the code for that. And again, it didn't really change that much except for this diff image part. And the OpenCV code for the actually doing the erosion is a little gnarly. But just as you sort a threshold of what you want to actually erode, and then there's this kernel here too that I wasn't really sure what it did, but it worked. And then I returned the result of all that, and I can show you all what that looks like. And one interesting thing with computer vision is that there's so many different areas that you'll dive into something that you don't quite understand, but you'll kind of figure out how to get where you want to go, and eventually you figure out what it is that you did. But this is not one of those cases. All right. So we removed more of the features of the image, but we got the general idea of the motion. So we removed as much as we possibly could, and only really removed the details that we don't need, and added the raw motion. It looks cool. I could do this all day. Jazz hands. There we go. All right.
Can I look at that code again? I'm sorry.
Yeah. Yeah, no problem. This one's a little more.
The road is some internal.
Yeah, it's some internal method.
You know what it's doing? Is it like doing a Gaussian and then I think it does sharpening it?
Yeah, something like that. I think that's right. Yeah, it takes in a threshold and then a road kernel, and then from that returns your result. And they're pretty detailed with their documentation, and there's probably something in a tutorial about it that you can read about. I think it's the only part. Yeah, that's the only part that was different from the others. So basically, all that is the gist of what my demo actually does. The only really difference, and maybe I can show you if I don't take forever. It's pretty rough, but it works.
Are you still doing all the audio generation in?
Yeah, all the audio generation is done on this machine with closure and overtone. That's just sending packets of data to this machine, basically to say which grid was activated. That's all it's doing, and it does it pretty quickly. So, which is what we want. RPCam. So some extra stuff I'm doing, if I can move my window over. If you can't read this very well, I'm sorry. One extra thing that I'm doing is actually detecting the black and white in the image to figure out where I am. So first off, I'm actually divvying it up into a grid, and basically check each grid and check for black and white. See if I can find where I'm actually calling that. Yeah, it's right here. So this is the point where I actually send the packet over to this machine. And let's go back to the black and white code. What's what?
How are you determining if it's black and white?
Oh, this code up here. Go back to that if I can find it. Basically, you're averaging all the pixels together. Let's see if I can get to a spot where I can read the code too. This has been a while since I've looked at this. So basically all you're doing is taking the mean of the entire image, and let's see.
Or slice in this case.
Yeah, that's right. Taking the mean of the slice of what you're looking at, and if it is, I can't remember if there's a threshold in here or not. I don't think there is, but if it's if the mean is greater than some value, then it will return. It's black. I have it backwards now. I wrote this like a month ago, and I can't remember what it does.
Is the image array a 2D array in NumPy?
Yeah. It's just so the number of the number of rows represent the height, and the number of columns in each array, like a subarray, represent the width. So like basically you're just manipulating each pixel, so I forgot where I was going with that, but that's right.
Where did you split it into a grid?
Down here. For and tile. So this right here, which then I have a generate tile up here somewhere. Yeah, this code is pretty gnarly. That's why I didn't really want to show it off. Yeah. I don't remember how that works. I think what I'm doing is actually generating, like, I'm calculating the pixel value of each tile, and then using that to split it up into cells. Let's see.
You've got a location of width and height.
Right. And then I'm breaking PEP3. All right. This looks like garbage, but it works. I'm going to show you my demo. All right. So, like I was showing y'all earlier, this is the actual camera. And the kind of cool thing about it is you can put it in front of something that maybe generates a pattern or cyclical or something, like maybe a ceiling fan, and it'll make this continuous pattern of sound. And it sounds really cool. And along with that, I have this thing. If I can get out of, there we go. Excuse me a second. I have this thing. See? It's called a refinement. So I can actually, this thing, you might have heard of OSC. It's a networking protocol for networking instruments, musical instruments. And this is how that communicates, how this communicates. And it's sort of like a guitar. So has a little fingerboard that looks sort of like a guitar, and it's tuned in the same way. Exactly. So I can actually play along with whatever's going on. And actually, I have it set up to where it's supposed to change chords, but it's not working right now. But this is just in my demo, and like what I want to really do with this is, and the reason why I have it set up the way I do, is I want to have this like set up different these cameras around the city and play the city with this camera, because I'm really interested in what kind of patterns would generate really interesting sounds. I think that's it, unless anybody wants to play with, if there's any, one cool thing to do is maybe play a video and put this in front of it. It's a good idea. What? What? Oh. Are you still gonna play video?
Yeah, what? Here we go. I'm flying over the Green Canyon. That'll be good.
I have to move it further away.
There it is.
Okay. You can get the gist. It's pretty cool. Put the sack back over it. If anybody wants to play around, so that's the end of my demo, or end of my presentation, I guess. I think I got maybe another slide I can show, but it's basically just questions. Okay. So how about, you might have any questions, or? Yeah, sure.
So does the proximity affect the volume of like the music that's playing?
Do what?
Does the proximity of like how close you are to the?
No, I don't. I control volume completely from this machine,
Okay.
but I could do that.
The camera doesn't know how close you are to it.
Okay.
Yeah.
The only way to, like, because Alex has done some cool stuff with extracting depth information, not extracting depth information, making up depth information from an image. But like the way to do it, if you really wanted to know how far away you are, is have a light source coming from approximately the same location as the camera, and then it could measure the brightness of whatever it was.
And you could probably do corner detection, maybe, to figure out depth. And actually, there's a built-in algorithm for corner detection if you wanted to look into that.
Do you also like throw in a connect?
Yeah, the Connect's probably better for that. But I think for what I'm doing, the Connect didn't seem appropriate. Any more questions?
Yeah, why did you choose the banana pie over the raspberry pie?
Well, so the banana pie, let's show you all again. As far as specs go, it's pretty similar to the new Raspberry Pi 2, or is that what it's called? Yeah. But the difference is this has a gigabit Ethernet port, and I wanted to sort of play around with, since we are a gigabit city, maybe use these in my experimentation, and like this wouldn't be like the actual device wouldn't be the bottleneck. Although I haven't actually done a bandwidth test, so it probably do gigabit
The key better thing with the gigabit Ethernet on that is it's a native Ethernet controller. It doesn't run across the USB bus.
Yeah.
So like the webcam, if you did this on a Raspberry Pi, there would be resource contention because there's only really one root hub on the Raspberry Pi, and so the webcam would be in contention with your Ethernet. So it would work probably, because you're not pushing a lot of data.
Yeah.
But the latency would be much higher because not only would it have to go through a USB bus, but it might have contention and have to wait for a bus to clean.
Yeah, and I'm sort of surprised with the latency between that. It's not that bad. It's not that bad at all. And with higher level languages, you don't really expect to get as much speed as I did on this. So I'm pretty happy with using Python OpenCV. I probably won't move away to Clojure on that. I highly recommend it. Any more questions?
I don't know if you mentioned this earlier, but why the project? Why?
Because I felt like it.
Just to experiment?
Well, so I used to work in Rome, Georgia, and one of the head over the makerspace there had this idea for generating music from your city, and we never really got around to working on it. Mainly, probably for one thing, the technology as far as that was available to consumers really wasn't there yet, and so it really never went anywhere. And maybe about in maybe January, the thought popped up in my head again, and I just decided to do it. And here it is in its prototypical form. And actually, it wasn't that hard to do. The hardest part was researching the motion detection and figuring out what I wanted and figuring out what worked and didn't work. I actually found a bug this weekend on the software that runs on the Pi. So yeah, I'm really stoked about this project. I have to maybe get it into maybe formalize it a little more, get it a little more polished a little bit, but it's sort of a mix of a previous want and just because.
Well, it's also a combination of two your passions, right?
Yeah.
You have a music background.
Yeah. Yeah, I do. So it's music and data. It's a music and data project, and those are two of my big passions. And combining those things together, and art too. Tech and art is awesome. And I think projects like this are a great way to sort of exemplify that. And also it's fun. It's just fun. If I don't enjoy it, then I'm not going to do it. So that's how I live my life. But is there anything else?
Have you thought of any place that you want to replace the around town?
I hadn't thought about that yet. I just actually thinking about getting this working. But I'm kind of interested in the front of the library. I think it'd be kind of cool. There's a good bit of traffic there. In front of another place where I got the idea from is seeing those during Christmas, the Frozen animatronics.
EPBs?
Yeah, EPBs. I got the idea from that too. So I thought, yeah, I when I saw those, I'm like, man, it'd be really cool to have a camera looking you in the face and doing something while you're moving. It'd be really cool, and that's where part of the idea came from too. Did I answer your question? Okay, because I actually forgot what you asked. All right.
Where would you place them?
Oh, yeah. Okay. Do you have a question?
So, have you played with other aspects of OpenCV? So, like, if you decide that you want to take music videos of this and put them up on YouTube, could you capture that video stream and would it be relatively easy with OpenCV to save it off to a file somewhere? Or would you have to potentially do it?
Oh, you mean actually save the generated?
The black and white.
Yeah, to actually save that? That's actually kind of easy. You can actually do that. It's a short answer, yes, you can. It's pretty simple, but I can't remember how to do it. It's like one call, and probably I'm not sure if you can actually you save the video like that a video, but you can save each frame and then later sew it into a video. But you could this
Might be a better server workload.
yeah.
You just push the video frame with the packet or something.
Yeah.
on the server.
Yeah. Yeah. But it does, and actually the newest version of OpenCV is actually version 3, and this works with, I think it'll actually work with 3, but some things tend to not work, but I forgot to mention the version. So this is OpenCV version 2.4, and the current release is 3. There are some compatibility issues, but I think this code will work with the newest OpenCV. And there's a good bit more algorithms in OpenCV, so definitely check that out. I haven't yet, but yeah. Any more questions or thoughts or?
We should take the traffic cameras. Straight line.
I wonder if we could get the feed from this. If we could, that'd be great.
What if you put it in the open art spaces on yesterday's board?
Yeah, I thought about that too.
Have an outside speaker and just have the camera of people passing.
Yeah, and I could probably even set up a, what is it, RT, I'm forgetting. There's a protocol for streaming sound. Could probably do that too, either way, with a speaker or actually stream it over the internet. That'd be cool. Yeah, that would be cool.
We talked.
You can,
We
yeah.
talked a while back ago, or me and Sean were just talking about this project, and it could also be cool to stream it to just like a web page too. So the person walking by could put in headphones on their phone and kind of have maybe a more intimate
Yeah.
thing, and that way you're not like also like broadcasting it out like crazy too. If that was an issue.
I don't think it would be. I think you'd be a lot more likely to get like somebody to dance like crazy if there's an effect happening.
Right.
Of it.
That's true. Instead of just
It's
like,
like somebody with headphones on, like
silently
whoa.
flailing around. Yeah, that's
Yeah, one thing I'm not totally happy with is my grid code. Like, it's sometimes it's not. It just doesn't sound like I think it should, even though it's sounding like it should. If that makes sense.
Sounds like you told it to.
Yeah, it sounded like I told it to. So I just sort of figure out sort of mix between what I want to hear. Yeah,
Could you do some sort of vector extraction out of it and use that?
probably.
And then like split instead of doing it instead of doing your notes on a grid, do them on like an angular,
Ooh.
and then use the vector for intensity or something like that. Like
That's a cool idea.
I don't know.
I don't know if I could.
I think CV can do the vector
Yeah.
extraction. I'm pretty sure.
Yeah, that's a great idea.
You probably just have to keep up with a few more frames. You might eventually run out of RAM on the banana.
You know, actually, it's pretty good. It's not bad at all. I could probably keep a good bit more than I am now.
I think vector extraction would be cool. Because then like how you move your hand would change.
Right. Indeed.
Thanks, Sean.
You cool?
Yeah, very cool.
All right.